So good morning all. This is the video lecture on data structures. So we are currently discussing with module 5, that is graphs. So what is a graph? We have seen. So graph is a non-linear data structure which consists of vertices and edges. So each and every n number of vertices and n number of edges. So each edge is connected between two vertices V1 and V2. So next we have seen two different types of graphs. So first one we have seen directed graph, undirected graph, directed acyclic graph, complete graph and multi-graph. So apart from that, so we have seen some of the graph terminologies like vertices, edges, path, network. So next we have gone with a strongly connected graph and weakly connected graph. So all these are terminologies. Okay. So apart from that, now you go with how you implement the graphs. So implementation of graph. So that for that we have gone with the two methods. So it is very, very important from exam point of view. So kindly understand. So this question is very, very important for your examination. Okay. So graphical representation, implementation using adjacency matrix and adjacency list. So first implementation, we go with the adjacency matrix. Okay. So how you are going to have the graph? So here we are considering a directed graph. So here you can see directed means each and every nodes are connected with directions. Okay. So what is that? How you implement using directed graph and how you implement using adjacency list. One is adjacency matrix, the other one is adjacency list. So that we shall see in this particular lecture. Okay. So first you come for the adjacency matrix. So you all know what is a matrix means. So matrix is a set of elements represented in rows and columns. Okay. So here we can see the connected vertices are the ordered pair in the matrix. So adjacency matrix is a sequence matrix. So sequence from 1 to 2, 1 to 3, 1 to 1 to 1, 1 to 2, 1 to 3, 1 to 4. It is a sequence. Okay. So similarly, 2 to 1, 2 to 2, 2 to 3, and 2 to 4. Similarly, 3 to 1, 3 to 2, 3 to 3, and 3 to 4. So now you see that the adjacency matrix is a sequence matrix with one row and one column. So row we have 4 vertices and 4 columns. So all the rows and columns will represent the nodes only. So vertices will be represented in both rows as well as columns. So one row and one column. The value of the matrix are either 0 or 1. Okay. So value of 1 for row 1 and row I and column J. Okay. So value of 1. When you put 1, when there is an edge from row one vertex to another vertex. So then we put 1. If there is no edge, so we represent it as 0. So value of 1 for row I1 and row column J implies that edge Eij exists between V1 and V2. Okay. So value of 1 for row I and column J implies that there is an edge between V1 and V2. So value of 0 implies that there is no edge between V1 and V2. So now we shall see in that thing. This is a directed graph. So see here. So 1 to 1, 1 to 1, there is no edge, 0. 1 to 2, there is an edge. So they are represented as 1. So keep in your mind, it is directed graph. So 1 to 2 is there, but 2 to 1 will not be there. Okay, that is the concept here. In directed 1 to 2. So 2 to 1, there is no value. Okay, so 1 to 2, there is a path. That's why we have given it as 1. 1 to 3, 1 to 3, there is no path. Directly you have to see. So it is moving from 1 to 2 and 2 to 3. That cannot be a path. So from 1, there should be a direct edge to 3. Then we can tell it as there is a path from 1 to 3. Okay. So that's why we put 1 to 3 is 0. Next 1 to 4 is also 0. Next you come for 2. 2 to 1. Is there a 2 to 1? No. 2 to 1 is 0. 2 to 2 is also 0. 2 to 3 there is a path. 2 to 3 there is a path. That's why we put it as 1. 2 to 4 there is a path. That's why we put it as 1. Next you come for 3. So 3 to 1. 3 to 1 there is a path. 3 to 2 there is a path. 3 to 3 no. 3 to 4 no. So that's why 1 1 0 0. Next you come for 4. So 4 to 1 0. 4 to 2 0. 4 to 3 1. 4 to 4 0. So this is the adjacency matrix. Okay. So adjacency matrix, what you have to consider for the graph implementation. Okay. So if there is an edge from node 1 to node 2, so vertex 1 to vertex 2, then the path is 1. Value is 1. If there is no edge from vertex V1 to V2, then it is given as 0. Okay. So now you come for the second implementation. So adjacency list. So list means, keep in your mind, it is linked list. Okay. So for n rows in the adjacency matrix, make them linked list. Make them linked list. So how you will be making that we shall see. Okay. So first you see. So first you write all the things. Vertex V1, vertex 2, vertex 3, vertex 4. Okay. So now you represent. So how you can represent? So from V1, there is a path from vertex 1 to vertex 2, there is a path. So that's why we have given it as V1, then vertex 2. Okay. So next you go with the next thing. So vertex 2. So vertex 2 is having a link to, first you are having for 3. So from vertex 2, there is a path to vertex 3. So you can see here also. From 1, you are having the link to 2. So first you have to write all the vertices in linked manner. It is one line. So 1 is linked with 2, 2 is linked with 3, 3 is linked with 4. Okay. So next 1 is linked to 2. You write that one. 2 is linked to 3 as well as 4. So first you will be writing 2 is linked to 3 and next you have to see 2 is linked to 4. That's why we have to write like this. So from 2 it is linked to 2 and it is linked to, from 2 it is linked to 3 and it is linked to 4. So that's why we write 2 to 3 and 3 to 4. So don't think it is, there is a path from 3 to 4. It's not like that. From 2 it is going first to node vertex 3 and there is a path to node 4. That's why we are writing like this. Okay. So come for the node 3. From node 3, where are the things you are getting? From node 3, you are going to node 1 as well as going to node 2. So that's why from node 3, you are going to node 1 as well as node 2. Okay. So come for the last. So from vertex 4, there is a thing to node 3. Oh, sorry, this is not vertex 2. It should be vertex 3 because there is a path from vertex 4 to vertex 3. So from 4, you have to go with a vertex 3. This is not 2. So this is 3. Okay. So from 4, where are the things going? So here you can easily check. From 1, it is 2. So from 2, you are getting 3 and 4. From 2, you are getting 3 and 4. From 3, you are getting 1 and 2. 1 and 2 are written. From 4, you have to go with 3. So here it should be 3. Okay. So that is the link adjacency list representation. Okay. So for n rows, So for n rows, make them linked list. There is one for each vertex. Each node will have two fields. One is the data field, the other one is link field. Okay, so data is the indices of the vertex adjacent to vertex I. If we want a weighted edge, have the third field. So positive, it is easy to visualize. Negative, it may go with how many edges. There are combination of links and arrays and links also. So this is the graphical implementation of graph. How you are going to implement the graph? Using adjacency matrix. The other one is using adjacency list. Are you people getting? Are you people getting? Sinchanayan. Sinchanayan. Next, Kavana KP. No. So now you come for the university question. It was asked in your university. So what is the thing? Define graph for the given graph. So they have given some graph. Show the adjacency matrix and adjacency list representation. So linked list, okay. So adjacency matrix you have to write, and adjacency list you have to write representation of the given graph. Okay. So first you come for the definition of the graph. So what's a graph? It is a nonlinear data structure consisting of nodes and edges. Okay, so it is consisting of nodes and edges. So nodes are sometimes called as vertices, and edges are arcs that connect two vertices. So it is defined as it is a finite set of vertices and edges which connect a pair of nodes. You have to write this one. It is one of the university question what we have taken. So the graph is a set of vertices and edges. So you can write this one or this one or this one. Any one you can write as definition. So we write G is equal to, what is G? G is the graph. So inside the graph we consist of set of vertices and edges, where V is a set of vertices and E is equal to Vi comma Vj. So Vi and Vj are in V. So this is the definition of the graph we are having. Next, now you have to show adjacency matrix and adjacency list. So come for this, you take this one as example. So for seeing that, you have to write this one. Okay. So how many nodes are there? Kindly you see A, B, C, D, E, F. So put all A, B, C, D, E, F in the manner. So first you see. So A to A, there is nothing, 0. A to B, there is a path. So put it as 1. A to C, there is a path. Put it 1. A to D, there is a path. Put it 1. A to E and F are not connected. So next you come for the B. So B to A, you put it 1. B to B, 0. B to C, 1. B to D, nothing. B to E, it's there. B to F, nothing. Now you come for the C. So C to A, no, 0. C to B, 0. C to C 0, C to D it's there 1, C to E 0, C to F 1. So come for the D now. So D you are D to A 0, D to B 0, D to C 0, D to E is there, so put it 1, D to F is there, put it 1. So come for the E. So E is not having anything going from any other nodes. So for E you put it all zeros, for F also you put it all the zeros. So now this is the adjacency matrix. So 1 for path going to adjacent, 0 for no path. So now you come for the adjacency list. So how you write the adjacency list? So from you see this one, if you see this one, you can easily write. So from list adjacency matrix, you can easily write. See here, from A to B, then A to C, then A to D. So that's why we have given it as A, then B, then C, then D. So finally, the linked list slash means it will end with 0. So come for B, B to A, next to C, next E. So from B to A, then to C, then to E. Okay, come for C, directly you go with a D and, sorry, it is F. So for C, it is D, then F. So it is not E, it is F. Okay, so come for D. So for D, finally you have E and F. So E is not having anything, so it will have slash. F is not having anything, it will have slash. So understood how to write adjacency matrix and adjacency list? So this is writing adjacency matrix and the list. So now you come for the next slide, that is graph applications. So what are all the things we do in the graph applications? So first application we have circuit networks. So what are the vertices? So you are connecting from one switch to another switch. Network means a group of nodes will be there. So how you connect from one computer to another computer. So that is called as a vertices means. So vertices are points of connection and edges are component wires. So first circuit networks, inside that, so network means group of nodes or group of systems connected together. So that systems will be called as a vertices, and if they are connected to each other, if two systems are connected to each other, then we call it as edge. So edge means it is a wire which is connected between two systems. So now you come for the transport network. So if you are transporting from one node to an n number of nodes, so what you will be having, vertices will be stations and edges will be routes from one node to another node. So next you come up with the maps. So map means you are connecting from one location to another location. So if you have used, the example is Google Maps. So example is Google Maps. In that you can go with a source to destination with n number of places. So what are the vertices? Places inside the state. So places inside the state and their distance between the two places, we call it as an edge. So that is adjacency relation. Next you come with a program flow. So you are our program concepts. So when you will go with the program concepts, so first you will be, vertices will be, so if you are containing two program with a function, okay. So vertices means first you have main function, next you have some other functions, okay. So calling function to called function, we call it as edges. So this is edge means link from calling to called function. So that one we can take it as edges. Okay, so this is in our program. This is in Google Maps, transport network, and circuit networks. So these are the graph applications what we can see. Okay, so now you come finally. What are all the reviews? So review, you have to understand what is a graph and degree of a graph. So what is the graph? Graph is a, so here you can easily understand what is graph. It is a non-linear data structure which is consisting of nodes and edges. So nodes are called as vertices and edges are called as arcs that will connect any two nodes in the graph. So it is also defined as finite set of vertices and set of edges which connect pair of the nodes. So this is the graph concept. So next, degree of the graph. So how you find the degree of the graph? So sorry, here the degree of the graph. So degree of the, you can find it for a vertex. So degree of a vertex in a graph is number of edges. So how in that number of edges from to or from that node. So out degree is number of outgoing edges from the node and in degree is number of incoming edges from the node. So strongly connected and weakly connected. So where you have seen this strongly connected here. So graph is strongly connected if it contains a directed path from U to V and directed path from V to U. From U to V, it should be connected. So this is strongly connected because there is a directed path from 2 to 4 and also a directed path from 4 to 2. So that's why we call it as a strongly connected graph. So weakly connected. So weakly connected means if by replacing all the directed edges with undirected edges, if we replace all the directed with undirected, which produces a undirected graph. So that time we call it as weakly. Okay. So weakly connected and strongly connected. So that are the important questions what we are going to review in this particular concept. So next you go with a set of references. So these are the references what we have seen and this you can refer. Okay, so this is up to the particular lecture on graph implementation and applications. So in how you implement the graph, one using adjacency matrix and the other using adjacency list, and finally we have gone with the graph applications. Understood? Understood up to here? Reply, have you understood? So use this attendance link to answer your attendance. Okay, so this will be up to today's class. So in that we have gone with graph implementation and applications. So next we shall see the next. So next you upload. Okay, so this is up to this particular lecture. So I hope you all got understood this particular concept. If not, if you are getting any network issues, kindly it will be uploaded in my YouTube channel. So YouTube channel ID is 1DPMK. So kindly subscribe for the channel. So understand the concepts by going through the videos. Okay, so here I will be ending this particular session. Thank you, one and all.